because this program and all the electric home may use the 24 kilowatt hour day in the total. So 40% is being used for the hot water and the cooking are consumed at 10% and part of the heat is vented outside in raincoat. So those things are to the heat. So this means that total energy is for 24 hours. Total 24 kWh. Total energy is a 24 kWh. So from the 24 kWh, so we are using 40% for hot water. And 10%. So 10% we also utilize. 10% is utilized for the cooking. So this is what I told you, is 10% is cooking. And also this one is amount of 10%. Heat is vented outside the range. So this is a part of the heat. The vented outside. Okay, so this one, this is the total is a 40% is the hot water, 10% is cooking, and the half is a vented outside. So this means how much heat go to the home to the heating effect of the appliance. This means that we have to calculate to the heating effect of the appliance. So then we do the 40% hot water, they produce the heat, and also 10%, but not all 10%, only half went outside. So this means that we can calculate to the and to the heating effect. To the heating effect. So the energy is at 24 kWh. So 40% is the hot water. So 0.4 plus 10% cooking, 0.1 multiplying half. So this is for the daily. And for the whole month, it's a 30 days. Then you can calculate so the heating effect by this way. So the conduction heat transfer, we calculate conduction heat transfer, and also we calculate the ventilation heat transfer. And this is for the airflow. Then also we also have to calculate for the heat gain via the occupant. So in the buildings that they are the occupant, some appliances that they are producing heat, and also the people are they also producing the heat. So now we will calculate the heat produced by the occupant. Calculation of the heat gain via the occupant. Heat gain the occupant means that people are living in the home, so we are focused on the people. So the heat gain depending on the number of people in the home. Number of people in home. Because the more number of people, the more that they produce the heat. And also depending on the number of our people are at home. So the number of our also depending on, and also the activity rating of the people. So activity rating. Activity rating means that some people are sitting down, some people are walking. So depending on the kind of the work they do, so their heat production will be different. So that those things we can so need to be we require no information to calculate the heat gain due to the people. Heat gain by people. So first we can calculate. And another one will be that not only the people, also in the building we also got the appliance. So the appliance power rating affects the heat gain. So this is the power rating of appliance. And another one is the number of hours the appliance are used. So this combination. The two combination can combine to calculate the heat gain due to appliance. then we combine the heat gain due to the prepare heat gain due to the appliance. Then the final result will be the heat gain due to occupant the appliance. So we calculate the heat gain by this way. Okay, another one, so this is for that we calculate the heat gains through the by the occupant. Another one with the key are also passing through the door and window. So heat usually pass through the door and window. So the door construction and window construction, the side of the window area, door area, and also kind of the glasses utilized and also shading effect. They also influence the heat transfer. So then now we also want to calculate the heat gain through the solar radiation or the glazing. So we have to consider how many glass, kind of the glasses. Kind of the glass we also need to consider whether those glass are shaded or unshaded. So the influence influences to the heat transfer. What is the window area, how many windows, and also how the sun hit on the door and window. So this is the angle incident. Those things are also influence the heat transfer through the door and window. Now I give you the flow chart to calculate the heat transfer through the glazing. Can you calculate for it? Solar ionization. So normally here is a direct, there is a direct impact happens due to the horizontal solar irradiation. The horizontal solar irradiation is influence the heat and also the E wave. So this is the E wave and also windows are high in the placement. So those are the factors for the door and window. Also the irradiation, E wave, and the window higher placement. So this is the window where you allocate the window, the east side, west side, north side, south side. That their heat gains is different. So that if you want to calculate the heat gain through the door and window, you also need to know that where the doors and windows are allocated. This way, we can calculate the solar irradiation on window. Okay, this is for the solar irradiation of window. And another one is that the heat is passing through the window. Some heat will be reflected, some heat will be transparent. So this transparency section of window affects the heat transfer. So we also have to consider the transparency. Transparent section of window. And also the window area. So those the effect the window. So this means due to the solar irradiation and those the combination determine the irradiation on the glass. So this is influence, and also we also have to calculate the internal blind casting and the side of the glazing. So those door and windows we also install the blind casting. So those blind casting and the side of the glazing they also influence the heat rate. So all of those you install the casting. By installing casting, it can also affect the heat rate. So we also have to calculate the internal blind casting. And also the type of the glazing. So this way we affect the shading effect. shading coefficient. They are the influence shading coefficient. So another one is the shading coefficient. Shade also the affected by the angle incidence. So then we calculate. So those combination affect the solar heat gain. So this is the solar heat gain. Affect the solar heat gain. So in addition on the glass and solar heat gain, the finite combination will be the heat gain through the glass. So this is we calculate the heat gain through the window. Other time, so did some technical data. So if you use the bridge, so heat absorbance data are 0.26 to 0.68, concrete is 0.05, and galvanized iron is 0.3 to 0.75, cement is 0.45 to 0.75, and paint is 0.18 to 0.9. So those are the terms are the building material. Commonly used building materials are heat absorbance data. So by using this one, you can calculate the absorption. So the heat you have to calculate this is specific heat. So what specific heat? So the volume multiply the mass multiply specific heat multiply temperature difference, then you can calculate the heat. So those are given for the heat absorbance. And then we also say if you use the comfort temperature, it's ranging from the 22 degrees centigrade to the 28 degrees centigrade. So the total heat transfer is depending on the people produce the heat, and also the heat transfer through the glass, heat transfer through the wall, roof, and the appliance, and the auxiliary equipment. So they have to be calculated and have to be the combined. So this is another formula, the total heat transfer formula. Okay, so now we will calculate the energy and temperature change process in the whole building. Now we talk about the total heat gain and heat loss due to the appliance, the heat gain through the door and window, and heat are produced by the people. So those are we calculate step by step, and everything we now have combined. Combined for the energy and the temperature change process in the building. So the whole process are we this is overall diagram, energy and temperature change. Process in building. So we calculate the heat flow due to temperature difference. We have to calculate heat flow due to temperature difference. And then we calculate the solar heat gain by wall. We calculate the solar heat gain by wall. And also we calculate the solar heat gain by roof. Solar heat gain by roof. And then the solar heat gain through the window. Solar heat gain through windows. So we calculate the heat gain due to the occupant and appliance. Heat gain by appliance and occupant. And then there's heating and cooling auxiliary. Heating and cooling. So those are the we calculate the heat factor. So heat gain and heat loss, they passing through the door and window temperature difference, point of temperature difference, it can happen the heat gain and heat loss, and also the heat gain from the wall. You also have to calculate the heat gain from the roof, and window, and the appliance, and the heating and cooling, the auxiliary heating and cooling. So everything that these are combined, then we can calculate the total heat gain and loss. So then we have to combine. Then we calculate the total heat gain or loss. And then we have to calculate this business out, we have to calculate the total heat gain or loss. And then then we say there are two guys. One is the building mass heat gain or loss. Building mass heat gain or loss. And another one is the air heat gain or loss. So then that one brings the first we just go to the change air temperature.
So this is the formula to calculate total heat gain, heat transfer. So P total equal to P temperature difference plus P glass plus P wall plus P roof plus P people plus P applies plus P auxiliary equipment. So in this case, there will be all the temperature power heat gain through the temperature difference, heat gain through the glass, heat gain through the window, heat gain due to the roof, heat coming through the emitted by the people, heat emitted by the appliance, and heat emitted by the auxiliary equipment. So here with the people equal to body heat from the people, P applies get the heat generated by the appliance, P auxiliary is a heat or cool generated by the heating or cooling plus. So those things have to be combined, then you can calculate the total heat transfer. Based on the total heat transfer, we can then determine the size of the air conditioner, size of the heater, and then we can calculate the required electrical power.